Okay, so now we want to look at the mean and standard deviation of a binomial random variable. I know how much you guys love the sound of standard deviation, as it takes so much time to find, right? So we are going to actually find it in an easier way. This theorem here tells us that if we take the mean mu of a binomial random variable with n trials and probability p of success on each trial is given by mu equals n. Let's try that again. N. Nope, it's not going to let me. There we go. NP. Okay? That's the easy one. Yep. So let's look at example 1A. Example 1A says for each of 4 days. So what do you think our N is going to be? 4. Good. A radio station is holding a raffle to give away a pair of tickets to the upcoming concert. In the past, the station has found out that 80% of the raffle entries are from the local area. If this is the case, find the mean of the random variable x, where x is the number of winners from the local area. So what is p in this case? 0.8. So what is mu going to be? 4 times 0.8, which happens to be 3.2. That's it. No, for this answer.
Why did you not teach us a long time ago? You just made us.
No, but that doesn't work for non-binomial stuff. This is a binomial distribution, so it works for this, okay?
So, is this all 10 is?
Basically, we got to find standard deviation. I want to do one of those too. So look at number 1B. Okay? 1B says, Chris is a basketball player that makes about 30% of the 3-point shots he takes. If he takes 8 shots in a game, what is mu?
Okay, so it would be 8 times 3 points, or 0.3.
8 times 0.3. Correct. And that's going to be 2.4. Ta-da! That's it for that one.
So is that like all this?
Okay, so.
Wait.
So what's it like taking our test or second grade?
Recall that there are 2 ways to find variance of a random variable. The first way to find it, remember it's this little baby standard deviation, okay? Looks like this. It was the sum of x minus mu to the second power times the probability of x, okay? That's the hard way. We want to go the easy way. So the second one to do this, I'm going to demonstrate this to you in a minute, is the sum of x squared times p to the of x minus mu squared.
Missy, when are we going to know when to use?
Okay, so it says in a binomial distribution with n trials, probability p of successes on each trial and the probability of q, failure on each trial, the variance is n times p times q.
See, but this is pass-fail.
Mm-hmm. So we're looking at the standard, the variance of a pass-fail situation, okay? And the standard deviation of that is what, do you think?
N times Q.
It's going to be npq again, but what are we doing to it? Square root, yep. Okay, so I'm going to skip number 2A because that's theoretical and it wants to show you how we get to this. I want to go to 2B and 3A. Okay, so in the situation of example 1B, Chris is a basketball player who makes about 30% of his 3-point shots. We just talked about him a few minutes ago. It is 0.3 is his probability. N is what in this case? 8. And what is Q? 0.7, because it's 1 minus 0.3, so it's 0.7. So his variance is going to be 8 times 0.3 times 0.7. And that happens to equal 1.68. What's his standard deviation going to be then? Square root of that. Yep. So, yeah, this is just a regular. 1.30 it ends up being about. Yeah, this shouldn't be squared, you guys. Okay, let's try the next one. And we're almost done. I'm just moving it up a little bit.
Is that 0?
This is a standard deviation.
Oh, okay.
Okay. Example 3A. In the United States, about 49% of newborn children are female. Suppose a large hospital has 2,500 live births in a year. Let P of X be the probability that X female babies are born in this hospital.
And that just be 49% times 2,500.
Yes. So P is equal to 0.49. N in this case is 2,500. And if you multiply those together, you end up with 1,225. Why do you think that this one would be considered a binomial distribution? Boy or girl? Yeah, it's only two choices. So in a sense, it's a pass-fail type thing. Haha. All right, just joking. What is the standard deviation of this? Well, not yet. No, this is the mu, remember? Yep. So it'll be 2,500 again times 0.49 times what? 0.51. Okay, so the variance ends up being, well, we need to take the square root of this in order to find the standard deviation, right? So that ends up being 624.75. Okay?
I feel like I'm on the runway with this fan blowing, like it's snowing.
Yeah. Okay. Double check that for me. I can't remember if I took the square root of that or not. I think I did. This would be the square root of this. And what did you say, 24.995? Okay. I forgot to take the square root of it.
But you wrote it over there. So, okay, no, 620.
Number 3 says about 0.14, which is true. It's 0.14. P is 0.14. We might as well write that down.
Why is that?
I wanted to say 14%, but I got ahead of myself. Of the population of San Diego is of Asian origin. Suppose there is a job opening in the city that requires a person to live in San Diego. If 200 people apply, so N is going to be 200, for the job, let P of X be the probability that X of the applicants are Asian origin. What is the mean random variable? So mu is going to be 0.14 times 200. Okay, 28. Okay, so let's find the standard deviation. Okay, so that is going to equal the square root of NPQ square root of point. Okay, so 200 times 0.14 times 0.86. If you find that, that's going to be 4.91.
Wait, how did we get 0.86?